My name is Lakshmanarana. This is Ellen Brand of Chemistry. Today we are going to discuss about solubility concept in the solution chapter. So daily we are going to discuss EAPCET examination point of view, some of the questions and as well as some of the concepts which are very important in the EAPCET examination that we are discussing. So from the 4 days onwards, some gap will be there. So from the today onwards, again it will be start. So listen carefully. Today we are going to discuss solubility concept in the solutions. So first of all, what is the solubility? Solubility means the maximum amount of solute that can be dissolved in given amount of solvent at given temperature and pressure to form a saturated solution is called as solubility. So what is the solubility? I will note the definition. You also write along with me. What is the solubility? The maximum amount of solute that can be dissolved in given amount of solvent at given temperature and pressure to form a saturated solution is called solubility. So this is what the definition of solubility. So solubility ante the given amount of solute that can maximum amount of solute that can be soluble in the given amount of solvent at a given temperature and pressure to form a saturated solution, that is called solubility. So remember here, in case the polar components will be there, a polar solute can be soluble in polar solvents only. Polar solutes, nothing but polar solutes, nothing but ionic compounds. Ionic compounds ne manam polar solutes antam. Sir, polar solutes soluble in polar solvents లోనే soluble అవుతాయి. Then అలాగే so non-polar solutes that are covalent compounds soluble in non-polar solvents. Yes, understand my dear students? Polar solutes that are ionic compounds can be soluble in polar solvents. Then non-polar solutes that are soluble in non-polar solvents only. So here we can say that like dissolves in like dissolves in like, unlike dissolves in unlike, dissolves in unlike. That we can say it is there in the even textbook also, NCERT textbook. They are mentioned that like dissolves in the like means polar components can be soluble in the polar solvents, unlike dissolves in the unlike, nothing but non-polar solutes can be soluble in non-polar solvents. So before going to that, one of the point we have to discuss. I told that form a saturated solution. How does it form the saturated solution? So first, so in case solute, if you take when it is added into the solvent, then to form some of the solute will be dissolved in it. Then concentration increases. That we call a dissolution actually. So solute added to solvent, then concentration of solvent increases or solution increases by dissolution of solute. This is called dissolution. దీన్నే మనం dissolution అంటా ఉన్నాం. Then, so observe it carefully. So this is one of the container. Here solvent will be there. Solute is added to this. What is added? Solute is added. So solute, when it is added, it will be dissolved in it. The number of solute particles are increases. Once number of solute particles are increases, that we are calling the increase in the concentration of solution, we call. Okay, the number of solute particles are increases in the container, that will be collide with each other. Once they collide will be with each other, then again it can converted into solid. The crystallization formation takes place. So by collision of solute particles to form crystals. Remember, to form crystals. So the solid again, when it is dissolved and the number of particles are increases in the solution, again can be converted into crystals. So both dissolution and crystallization happens. So both dissolution and crystallization happens in the solution. That particular state is called as saturated solution. దాన్నే మనం saturated solution అంటున్నాం. సో ఏమేమి ఈక్విలిబ్రియం లో ఉండాలి? dissolution, then both are equilibrium with crystallization. Dissolution and crystallization, when both are present in the equilibrium, then we call it as saturated solution. Next, we have to discuss about the solubility of solids in liquids. Actually, the solubility of gases in liquids will be there. Solubility of solids in the liquids also is there. So, solubility of solids in the liquids. Sir, what are the factors for influencing on the solubility, that we have to discuss. The solubility of solids in the liquids depends upon the 4 factors. So note that solubility of solids in liquids is directly proportional to, depends on 4 factors. What are the factors that we have to discuss? So one is lattice energy or lattice enthalpy we call. Then one more, hydration energy. Then next one, pressure, and 4th one, temperature. These are the factors are affecting on solubility of solids in the liquids. So look at the 4 factors, whatever it is there. The factor number 1, the solubility of solids in the liquids. Factor number 1, lattice energy. Number 2, hydration energy. Number 3, pressure. Number 4, temperature. That will be there. So look at one by one, that we'll discuss. So what is the lattice energy generally? Lattice energy, nothing but the energy is released when the 1 mole of crystal lattice can be converted into its ions. For example, look at, sir, 1 mole of 1 mole of crystal ఉందనుకోండి, క్రిస్టల్ లాటిస్ ఉందనుకోండి. సో ఈ క్రిస్టల్ లాటిస్ ఆయాన్స్గా కన్వర్ట్ అవ్వడానికి ఎంత ఎనర్జీ అయితే అవసరం అవుతుందో, ఎనర్జీ ఇస్ రిక్వైర్డ్ ఫర్ ద కన్వర్షన్ ఆఫ్ 1 mole ఆఫ్ క్రిస్టల్ ఇంటూ దేర్ ఆయాన్స్గా కన్వర్ట్ అవ్వడానికి కావాల్సిన ఎనర్జీనే మనం లాటిస్ ఎనర్జీ అంటాం. నెక్స్ట్, వాట్ ఈస్ ద హైడ్రేషన్ ఎనర్జీ? హైడ్రేషన్ ఎనర్జీ నథింగ్ బట్, సో 1 mole of ions, 1 mole of ions వాటర్లో యాడ్ చేసినప్పుడు, దేంట్లో వాటర్లో యాడ్ చేసినప్పుడు అది సాచురేటెడ్ సొల్యూషన్గా కన్వర్ట్ అవ్వడానికి, సొల్యూషన్గా కన్వర్ట్ అయ్యేటప్పుడు సమ్ ఎనర్జీ విల్ బి రిలీజెస్. The amount of energy released, so delta H value is negative for this. Amount of energy is released when 1 mole of ions are dissolved in the water to form a saturated solution. Delta H value for this is negative. That is what we are calling it the hydration energy. So both energies, so first energy enti, first lattice energy enti 1 mole of crystal lattice can be converted into their ions. So how much amount of energy a crystal ni break cheyadaniki kavalsina energy. So actually a crystal, so like this, in the cubic formation it will be present. So ila untundi cubic formation. So ee cubic formation lo unna crystal lattice lo okkoka point daggara, oka lattice point daggara oka ion untundi. Sir ivanni kuda with the bonds, with ionic bonds, they are arranged. So these all can be converted into ions. Ions ga convert avvadaniki kavalsina energy, requirement of energy, that is called a lattice energy. Clear? Okay, now it is understand what are the factors. So temperature, pressure is well known, you know. So now if solid contains more lattice energy than hydration energy. So hydration energy kante lattice energy ekkuva unte, that are insoluble in the water, that solids are insoluble in water. Clear, my dear students? Understand? So next one, look at, if solid contains more hydration energy than that of lattice energy, that will be soluble. These are insoluble, that are soluble. Yes, if solids contains more hydration energy than lattice energy, that solids are soluble. So these are insoluble, that are soluble in water. Understand? So note all these points. Yes, next we'll discuss. So these are the lattice points, lattice energy, then hydration energy. So both, based on both we can discuss. So next, effect of temperature that we have to discuss. Effect of temperature on the solubility of solids in the liquids. So effect of temperature. Remember, so very important this is. So here two types of dissolutions are there, endothermic dissolutions and exothermic dissolutions. Once a solid, when it is added to water or solvent, we call water or solvent, in case energy will be absorbed by that particular solution. The solution form అయినప్పుడు ఎనర్జీ కనుక అబ్జార్బ్ చేసుకుంటే ఆ సొల్యూషన్ని, ఆ డిజల్యూషన్ని మనం ఎండోథర్మిక్ డిజల్యూషన్, endothermic dissolution we call. Then endothermic dissolutions are there when the temperature increases. Solubility also increases. If, that's what I told, if endothermic dissolutions are there, endothermic dissolutions are there, so if endothermic dissolutions are there, temperature increases, solubility also increases, solubility కూడా increase అవుతుంది. Sir, example example for these are NaNO2, then HNO2, so etc. These are the endothermic dissolution of solids. So even we can take then NaCl also we can take, then KCl also we can take, so etc. These are the endothermic dissolutions. Understand, my dear students? Then next exothermic dissolutions are there. So exothermic dissolutions ante so solid ni water lo add chesinappudu, so solid when it is dissolved in the water, then some amount of energy will be released from it, from the solution, then delta H equals to negative. This we call exothermic dissolution. Exothermic dissolution. When the exothermic dissolution are there, temperature increases, solubility decreases. Temperature increases, solubility decreases. Remember, for the endothermic and exothermic, what we are discussing, endothermic dissolution temperature increase aithe solubility increase avutundi. For exothermic dissolution temperature increase cheste solubility emoutundi, decrease avutundi. So examples for these such as lithium carbonate, then sodium carbonate, Na2CO3, then NH4 NO2, ammonium nitrate, NH4NO3. So these are the examples for this. So now if you take graphs for those, so look at all of you. So temperature effect, based on the temperature effect we are taking, we are discussing the temperature effect. Endothermic dissolutions and exothermic dissolutions we are seeing. If endothermic dissolution of solution will be there, temperature increases, solubility also increases. When exothermic dissolution is there, temperature increases, solubility decreases. Then here if you take graph for the endothermic dissolutions, endothermic dissolutions if you take, sir, such as solubility and temperature. So in this case you can take temperature, this case then solubility kanaka తీసుకుంటే, then in case if it is a KCl, then you can get a straight line like this, KCl. Understand, love? So what does it mean? the temperature increases. When the temperature increases, the solubility also is going to increase, right? Solubility also is going to increase. Then in case exothermic dissolution, if you take, and the delta H value here negative, then the delta H value here positive. So in this case, temperature increases, solubility also increases. So in this case, temperature increases, solubility decreases once exothermic dissolution will be there. Examples what I told, man. Lithium carbonate, Li2CO3, then sodium carbonate, Na2CO3, such type of components. So in this case, actually exponentially decreases. Sir, in case if you take the solubility here, then higher temperature if you take, these are the graphs you can get like this. If you take for this Na2CO3. So solubility will be decreases when the temperature is going on increases. Understand, my dear students? Okay. So next we have to discuss one more salt in this case, and the temperature effect itself. Some of the salts like hydrated salts, sodium sulfate, decahydrate, calcium chloride, hexahydrate. Some salts at the particular temperature solubility increases, then after it will be decreases. So remember, sir, which are the salts? So look at some salts. What are those I told? Na2SO4 sodium sulfate 10H2O and CaCl2 6H2O. Ilanti salts. So these salts at particular temperature solubility increases, temperature increases, solubility also increases. So look at the graph, we can get like this. So how it is? The particular temperature, in case if you take for the Na2SO4 10H2O, E salt kanaka manam teeskunte, so just assume it is a solubility, then this is temperature. Sir, solubility first ila increase avutundi, then it will be decreases like this. Oka particular temperature daggara solubility sudden ga decrease avutundi. Enduku sir? Why? What happens there? So why it is happens, So actual ga, sir, Na2SO4 it is present in one crystalline form. మనం సాలిడ్ స్టేట్ లో చూస్తాం, క్రిస్టల్స్ ఆర్ 7 టైప్స్. సో వన్ క్రిస్టలైన్ నుంచి అనదర్ క్రిస్టలైన్ కి చేంజ్ అయినప్పుడు, సార్ అనదర్ క్రిస్టల్ గా కన్వర్ట్ అయినప్పుడు, సార్ ఇక్కడ క్రిస్టలైన్ స్ట్రక్చర్స్ వి ఆర్ సీన్ CTO, HR, MTN. CTO క్యూబిక్, ట్రైగోనల్, H hexagonal, then R orthorhombic, monoclinic, triclinic, or there will be there. So these all are crystals. 7 types of crystals will be there. So oka type nunchi inkoka type ga convert avutundi oka particular temperature daggara. Danne manam emantunnamante transition temperature we call. Em transition avuta undi crystalline form, వన్ క్రిస్టల్ నుంచి అనదర్ క్రిస్టల్ గా అది ఫామ్ అవుతున్నప్పుడు అది టెంపరేచర్ మళ్ళీ సడన్ గా డిక్రీజ్ అవుతుంది. వాట్ ఈస్ దట్? సాల్యుబిలిటీ డిక్రీజ్ అవుతుంది ఒక టెంపరేచర్ దగ్గర. క్లియర్? సో వాట్ ఈస్ ద ట్రాన్సిషన్ టెంపరేచర్ మ్యామ్? ద టెంపరేచర్ at which one crystal form one crystal form can be converted into another crystal form. Another crystal form. That temperature is called as transition temperature. Okay, understand, my dear students? Then last, pressure effect. Effect of pressure will be there. Effect of pressure. Effect of pressure will be there. So solubility of solids in the liquids, effect of pressure, no significant effect, because, once again listen carefully, the solubility of solids in the liquids, no significant effect, because the solids are incompressible when the pressure is used. When pressure is used, solids are incompressible. So no significant effect. Nothing but that is negligible due to what reason? I told, incompressible. Solids are incompressible. Solids are incompressible. That is the reason these are negligible. Pressure is negligible at this case. Understand, my dear students? Yes, note down. Yes, listen, my dear students. So one more important point in it. Ionic solids dissolves in water, dissolves in some polar solvents with a high dielectric constant. So solvent which is having the high dielectric constant, that the solid can be more soluble in the particular solvent. So what does it mean? So I told that what is the statement I told? Ionic solids dissolves in solvent with high dielectric constant. I told dielectric constant. So what does it mean? What is that dielectric constant? Dielectric constant ante enti? So for example, H2O is there. H2O, so it is a solvent. Then H2O dielectric constant value. Dielectric constant value is 80. Then D2O, deuterium, that is we call heavy water. Then that is 78. Then one more that is methyl alcohol, in case if you take CH3OH, that is 33.5. One more DMF, dimethyl formamide, that is 37, dielectric constant value 37. Then at last one is given benzene, C6H6, that is 2.5. So ionic solids dissolves in the solvent with high dielectric constant. You have a doubt here. So what is the dielectric constant? So this dielectric constant ఏం indicate చేస్తా ఉంది అంటే, sir, which is having the high dielectric constant, that is capacity to dissolve in it more. సో ఏదైతే డైఎలక్ట్రిక్ కాన్స్టెంట్ ఎక్కువ ఉందో అయానిక్ కాంపౌండ్స్ అందులో ఎక్కువగా డిజాల్వ్ అవుతాయి. సో దిస్ వాల్యూ ఇట్ ఇండికేట్స్ హౌ వెల్ ఇట్ క్యాన్ బి డిసోసియేట్. యాక్చువల్గా సో ఈ అయానిక్ కాంపౌండ్స్, ఫర్ ఎగ్జాంపుల్ నేను NaCl తీసుకున్నాను. NaCl, ఈ డైఎలక్ట్రిక్ కాన్స్టెంట్ అనేది ఏంటి అంటే, సో దేనికైతే కాన్స్టెంట్ ఎక్కువ ఉంటుందో అది ఈ నెగటివ్ ఛార్జ్ని పాజిటివ్ ఛార్జ్కి మధ్యనున్న అట్రాక్షన్ని వీక్ చేస్తుంది, వీక్ చేయడానికి యూజ్ చేసే వాల్యూ దట్ ఈస్. సో విచ్ ఈస్ హ్యావింగ్ ద హయ్యర్ డైఎలక్ట్రిక్ కాన్స్టెంట్ దాట్ విల్ బి reduces the attraction between the Na plus and Cl minus ions like this. అంటే పాజిటివ్ అండ్ నెగిటివ్ చార్జ్ అయాన్స్ ని అట్రాక్షన్ ని రెడ్యూస్ చేయడానికి ఈ సాల్వెంట్ యూజ్ అవుతుంది. సో విచ్ ఈస్ హ్యావింగ్ ద మోర్ డైఎలక్ట్రిక్ కాన్స్టెంట్ దట్ ఈస్ మోర్ సాల్వెంట్, దట్ ఈస్ మోర్ soluble solvent in it. Clear all of you? Right. Next, one more point you have to remember, that are the compounds which are having the polar solvents that can be soluble in water. The compounds which are having non-polar groups that can be soluble in non-polar solvents. So look at compounds which has polar groups such as OH, NH2, then COOH. These are polar groups we call. Polar groups unte, so that are soluble in polar solvents such as water lo soluble అవుతాయి. సరే ఇలాంటి గ్రూప్స్ ఉన్నప్పుడు. Clear all of you? Right. So the compounds which is having non-polar solvents, compounds which are having non-polar groups అంటే so like n bond n or otherwise hydrocarbon chain which is hydrophobic part unte, so that are soluble in non-polar solvents. So what are the non-polar solvents, sir? Non-polar solvents, carbon disulfide, then chloroform CHCl3, carbon tetrachloride, then DMF dimethyl formamide, so etc. All these are non-polar solvents. So compounds non-polar groups unnavanni non-polar solvent lo, then polar groups unnavi polar solvents lo dissolve avutayi. Clear, my dear students? So these are the factors which are influencing on the solubility of solids in the liquids. So next we have to discuss about the solubility of gases in the liquids. The solubility of gases in the liquids. So note down all these 2 points. Next we will discuss the solubility of. Yes, look, my dear students, next topic, that is solubility of gases in liquids. So the previous topic we have discussed about the solubility of solids in the liquids. So what does it mean? What we have discussed in the solubility of solids in the liquids actually? So a certain amount of or a maximum amount of solute that can be dissolved in given amount of solvent at given temperature and pressure to form a saturated solution is called as solubility of solids in the liquids, right? So even here also same thing, but so here we are taken gases, so that's what the gases at STP conditions, the volume of gases. So look at the volume of gases in centimeter cube at STP conditions, in cubic centimeter at STP conditions, that can be dissolved in 1 unit of volume of water, 1 unit of volume of liquid or water to form a saturated solution is called as solubility of gases in the liquids. So general ga solubility of the gases in the liquids we can express in the mole fractions. So solubility of the gases in the liquids, solubility of gases in liquids can be expressed can be expressed in mole fraction. Mole fraction lo express chestam. Solubility of gases in the liquids generally can express in the mole fraction, that we have to discuss. So here the volume of gas 1 centimeter, for example 1 centimeter cube, when it is dissolved in 1 liter of water, that we call it as solubility of the gases in the liquids. Clear, my dear students? Right. So now, what are the factors are affecting on the solubility of gases in the liquids? What are the factors? So factors depending on the factors depends on solubility of gases in liquids, solubility of gases in liquids, that we have to note it. So solubility of gases in the liquids, ఏ factors depends అవుతా ఉన్నాయి. So what are the factors that we have to discuss? That are 4 factors again, same like solids and liquids. But here the factors are, one is nature of the gas. Nature of the gas. Number 2, nature of the solvent. Nature of solvent. Number 3, pressure. And number 4, temperature. These are the factors are affecting on it. Temperature, nature of the gas, nature of the solvent, and temperature and pressure. So first we have to discuss about the nature of the gas and nature of the solvent. Nature of the gas and nature of the solvent. These 2 factors, how it is depends on. So generally we have to discuss about the first nature of the gases. So some of the diatomic gases such as N2, H2, O2, Cl2, Br2, then I2, all these gases we are calling permanent gases. Permanent gases. So gases generally are dissolved in the water is very little extent. So gases in water soluble in little extent. Soluble in little extent. Little extent. Very little extent. Sir, for example, in case oxygen gas, in case if we take, so very healthy water, in case if we take 6.5 to 8 milligrams of oxygen only can be dissolved in the water. So remember what I told. Sir, in case fresh and healthy water if you take, in fresh and healthy water, dissolved oxygen, that is O2, contains only 6.5 milligrams to 8 milligrams only. 8 milligrams only. So this is called dissolved oxygen. Dissolved oxygen. A dissolved oxygen in the healthy water, how much is there? This much is there. That you have to remember. Dissolved oxygen in the healthy water, it contains 6.5 mg to 8 mg it will be present. Clear? So these are the gases. It can be soluble in very little extent. All these gases are non-polar. So that's what these are dissolved in very little extent. So here next in case, so polar solvents, so polar gases will be present such as CO2, then SO3, then HCl, so then NO3 or NO2 gases. All these are the gases which are present in it. SO2. All these are gases. The polarity will be present in it. So how the polarity will be present? So for example, in case if you take C double bond O is there. So C double bond O. So here carbon and oxygen electronegativity difference is there. The partially negative, then partially positive charge will be present. So in this group, polar will be present. The polarity will be produced in it. Polarity produced aithe. So not only in this gas man. So some other gases also is there, such as SO3 gas. Yes, then double bond O, then double bond O, then double bond O. Polarity will be present. So here partially negative charge, here partially positive charge is there. So polarity will be present. Even in this case also polarity will be present. So where the polarity will be there, that are soluble more when comparative to the permanent gases. The solubility of polar gases are more in the water when comparative to the permanent gases. So note down that. So these gases contains polarity in the group. So these gases we call polar gases. Polar gases can soluble more in water. More in water. So some other gases are there like ammonia and as well as hydrogen fluoride. So all these gases, so when comparative to these gases that can be soluble more and more. So which are the gases I told? Which are the gases I told? So two more. So NH3 ammonia and HFR. So when comparative to these gases, these are more soluble. More soluble. Why are more soluble? Because that can be formed hydrogen bonding. Hydrogen bonding. Due to the presence of hydrogen bonding, these are more soluble. Polarity of these groups are more soluble. Then these are non-polar components. So in between nitrogen and nitrogen triple bond is there. There is no electronegativity difference in between them. So polarity is absent. So when the hydrogen bond, hydrogen polarity is absent. Oxygen bond, oxygen polarity is absent. Clear? Okay, understand all of you. So these are just depends upon the partial pressure that can be soluble. Okay. Yes, these are the factors which are nature of the gas and nature of the solvent. So first point on this, permanent gases are little extent that can be soluble. Next, which are the polar groups are there that can be soluble more. Next, sir, in case if you take ammonia and hydrogen fluoride, then more soluble when comparative to all these because these can be form hydrogen bonding. Okay, okay, right. So next, pressure effect and temperature effect. The pressure effect of solubility of gases in the liquids can be explained by one of the famous law in the solutions, that is Henry's law. So that first we have to discuss about the temperature. So temperature, effect of temperature. Effect of temperature. Yeah. Yes. Look at. Sir, solvent is there? Any solvent like water. When it is added to gas, then one of the solution will be formed. So solution will be formed. So remember this, any gas, not only here, any gas. ఏ గ్యాస్ అయినా సాల్వెంట్ లో డిజాల్వ్ అవుతున్నప్పుడు that is we call exothermic dissolution. What we call exothermic dissolution. Exothermic dissolution. So exothermic dissolution, nothing but delta H value equals to negative, right? Delta H value negative. Exothermic dissolution. So we know that one of the point we are discussed in the solids and liquid solutions, right? Exothermic dissolutions will be there. Temperature increases, solubility decreases. So remember, my dear students, temperature increases, solubility decreases. Solubility decreases in this case. Why, sir? So because it is exothermic dissolution. exothermic dissolution లో temperature increase అయితే solubility increase అవుతుంది. So that is the reason aquatic animals like fishes, whatever the animals which are living in the water, aquatic animals we call. Aquatic animals are more comfortable conditions are cold conditions. So in the cold atmosphere, aquatic animals are, so they can live in very healthy way in water when comparative to when temperature increases. So remember, so that aquatic animals can live very healthy in cold conditions. Next we have to discuss about pressure effect of pressure. So what is the effect of pressure that we have to discuss? Effect of pressure ఏంటి? So here effect of pressure in case if you take, say definitely effect of pressure will be present because of the gases. Gases are very compressible when pressure is increases. Gases are compressible. Solids in case if you take, solids or liquids also, even liquids are incompressible. So here pressure effect will be present. Pressure effect is present in the gases, but here no significant effect. Because incompressible, already we are discussing. Say look at in case any gas, any solvent is there. Here the solvent is there. So here gas will be present. So atmospheric gas, it is present in the closed vessel. Just atmospheric gas, nothing but N2 plus O2, like this will be there. The pressure increases on the gas, the solubility of the gases in the solvent will be increases. Note down, pressure increases on surface of liquid. Solubility of gases increases. That can be explained by, the solubility of gases can be explained by solubility of gases in liquids. Mainly effect of pressure. Effect of pressure can be explained by Henry's law. Henry's law explain chesta undi. So in the next video we'll discuss about the Henry's law and Henry's law applications and Henry's law numerical problems that we'll discuss. So now only the theory topic today we are discussing. So just read theory topic, just listen theory topic carefully. Then remaining topics it will be understand very clearly to you. So that is what I given the information today, which is required for the JEE Mains and NEET examinations and as well as EAPCET examinations. So please subscribe my channel and share, like, comment. Thank you.